Alright guys, this video is going to follow up on a previous video where we had two instructions, the NormX and the ScaleX. We were, I wouldn't say halfway through, but a third of the way through the programming for our HMI. And so at this point we have, you can see right up here, I got 8 milliamps going into the analog input number 2. And we can see that being seen here. So that's what, 6,983 out of a total of 27,648. So in our example, and in most examples, 8 milliamps is 25% of the range. So you can see that right here. The NormX is taking this value, normalizing it to a value between 0 and 1.0, so 0 and 100%. This double word here, this MD50, is being placed into the ScaleX, and that value right there is then scaled between 4 and 20 milliamps. Okay, you see here that this is 4.0 and this is 20.0. because this is a real value, which is basically the same as a float, and that's being pushed out as a real value as well. And so you can see here that we have 8.04 on our display, and we've got 8.06 on the transmitter there. So a little bit of resolution difference between the actual transmitter right here and the program that's here. But so far what we've done is we've created like a kind of a base program here to get a value here that we're going to use a number of times to get like a percentage and an actual centimeter scale in the tank. And at this point we have a value that we can push out to the HMI showing the actual current that we're seeing in the circuit there. Sweet. Okay, so let's keep going here. You'll notice that I have, no you don't, because I got both screens here. I was going to say you can notice that I have the lab set up on the side. Let me get myself out of the way here, and then you'll see that I have the setup. Hang on 2 seconds. Just need the display capture. There we go. Okay, so we have the lab on the side here. And so you guys have it set up like this, or you have a full screen, so you can have, because you have a paper copy in front of you, but because I'm doing this on YouTube, I'm going to have the lab on this side right here. And then we're going to mimic that within the TIA portal here. So let me go offline here. Let me quickly show you, like if you're coming back from the previous week, or you're, on network 3 or network 4 or something, and you want to get back to your program, most likely that you probably have this guy open right here. If you don't, then click on this single arrow right here to expand. Okay, and these might be minimized here. Okay, so you'd have PLC and possibly the HMI. I'm not sure if we've added the HMI in yet. But this PLC here, we're going to click here. Okay, then we're going to do a single click on program blocks. And then we're going to double click on main OB, and then it opens up our main organizational block. Okay, once we have that open, then we can minimize this. Okay, and then for our instructions, we can click here and we can expand our instruction palette there. Excellent. Okay, so I have mine, fairly minimized here because I want to have as much of a zoom in as I can for the YouTube video. All right, so moving on to network number 2, guys. We're going to add in another ScaleX. So if you say you don't have network number 2, it's probably there because we added network 1. But if we don't have number 2, we're going to single click on this arrow right here. We're going to scroll down. We're going to insert a network. Okay, so now we have network number 2. We need another ScaleX. So that is, where is it found? It's been a while. Where is that, guys? Is that in math functions? No. Conversion operations? Yes, conversion operations right here. Okay, so there's our ScaleX found under conversion operations. So we can grab this, drag it down till it's green, and drop that bad boy in. The other way we can do this is we can delete that guy out. Hello. Okay, and just grab a empty box right here. So we're going to grab this, drag it down till it's green, let her go, and then in this window right here we put scale. If I could type, there we go. If there's our ScaleX instruction, click on that bad boy, click on anywhere on the screen, and now you have your ScaleX. Beautiful. So this guy is going to go with MD50 as the input. So we used MD50 up here. We're going to use it a number of times in the program to punch into different scale instructions here. So I have taken the time to put in all of my tags here. So I'm looking for MD50. So this bad boy right here. When I click somewhere else on the screen, then it comes in. Okay, so you should already have MD50 as well. So the way that I did that, I did it too fast here. I right-clicked on, no, I left-clicked on it. There's this menu that's here, and I went down to MD50, and then it came in. Okay, so we have MD50, and we're going to scale between 0 and 100. Okay, so be careful, just keep track of where you are on the page here, because this is an identical instruction, but on network number 3. So this one's going between 0. So you'll notice that once I put in MD50, it changed this to a real scale right here. Okay, so we're going from 0.0 to 100.0. So because it is a real or a float, sorry, my phone's going off, then that should come in. Now, for some reason, it's angry at us right here. Let's see if we can fix that. So we're going to change this output here. That's interesting. Let's see if we can change this. We're going to change this output to a real as well. Ah, yes, and then those guys went blue there. Okay, so if this is undefined, then these guys are angry at us. So we have to define this bad boy as a real, and we're good to go. Okay, our output here is going to be MD62. So let's find MD62. That's going to be our 4 to 20 to our 10 to 50 scale. Okay, the reason for that, if you missed the first video, is that we went from MD50. So quick little disclaimer. I started at 50 because I had like a larger program that I was working on, where I had a number of programs, a number of screens together, and at the point that I started this portion of the program, I was already at 50. But you can see that because I'm using a double word here, I have to go up by 4 each time. So I went from MD50 to MD54, and then I'm making use of MD. See, be careful. See, I looked at the screen and I screwed up already, right? This one is supposed to be MD58, right? So the next one in line is MD58. Okay, so be careful when you're reading the manual here. Dyslexia hits when you least expect it. I was looking down here. So MD58 would be our next one. 50, 54, 58. The reason why we're using like four more than the previous one is because we don't have bits between each word that are overlapping. That's going to screw up our program. Okay, so that comes in as MD58. There we go. Now, in order to put this in, right, so say I'm doing, like, I haven't used MD32, so let me do percent MD32, okay, you're going to be doing something like that. So for percent MD58, you'll be putting in percent MD58 first, and then you're going to right click, and then hit rename, and then you're going to put in 4 to 20 milliamps to percent scale, right? So I'm just going to put in random tag here. And once that's done, then it has the address and it has the name for it as well. Okay, if I just put in just useless tag here, right? So if I called this by a separate tag, then the PLC, see, it's red, it's angry at us. It's like, what do you want? What? I don't understand. Like, what do you want me to do with this? It doesn't tell me where you want to keep this in the memory or anything. I have no idea what useless tag is whatsoever. So you have to put in your address first, and then you can name it. If we're looking for all of the names, you can see here that if I go and single click on PLC tags, then double click on show all tags, come on. There we go. So these are all of my tags that I've put in there. So there you can see MD32. And if you screw up a name, you can always come to your tags and then change the tag here, right? So I can say, so different tag there. And as soon as I do that, if I go back to my main OB, so you'll see that I'm going back and forth between PLC tags and the main OB. As soon as I changed MD32, then it's available, right, where's MD32? There we go. Okay, so it's available with that new tag there. Okay, I'm going to get rid of that bad boy so I don't screw anything up here. Okay, so hopefully everybody's cool in that we are putting in the address and then we're putting in the name. So we're right clicking and renaming that tag. Okay, this one is 58. So let me get rid of this. Excellent. Okay. Let's name the network as well. So this is 4 to 20 milliamps to 10 to 50 centimeters of level. Okay. One of the reasons why we're doing that is because if our networks are all compressed here and we get into a much larger program, we can easily go to the network by seeing, you know, exactly what that network is actually doing there. So we're trying to put as many like descriptions in our tags and in our networks as well, so that it's easier to navigate. Okay, we're done network 2. Okay, so now we're moving on to network 3. So we're putting in another scale X there. So I'm just going to grab this guy, drop her down, type in scale, comes up, beautiful. Okay, we could have copied and pasted this guy as well. We're putting in a minimum of 10, so 10.0, and a maximum of 50. So you'll see that again I'm putting 50.0, and that is because when I put you see it's angry here, when I put in the tag, and I'm going to make use of MD50 as well. So MD50 again was the output of this Normex, and that's being placed into a number of different scale X's right here. So I'm going to choose MD50 as well. Okay, that's a real value, and again it has to have 10.0 rather than 10. Okay, and 50.0 rather than 50. Okay, my output again is going to be a real value. Okay, and I'm doing MD62, right? Because I got to go 4 up from here. So you guys are typing in %MD62, hitting enter, right-clicking, renaming. I've already done that. Try to minimize the amount of time that I'm spending on the video. The last video I said I thought it took a half an hour, and it actually took an hour. So you'll see that I'm trying to get through this as fast as possible. Also, because we only have two labs to get through this. So, and in 2 labs we have 4 hours. So there should be enough time to stay focused as long as you're not on your phone. Hopefully this is on your phone and you're listening to me as we go through. Okay, so network 3 is for what? Let's see, 4 to 20 milliamps to 10 to 50 centimeters level. So that's taking our 4 to 20 milliamp signal and changing it to a 10 to 50 centimeter level. And I think I screwed this up on the previous one, didn't I? Yeah, see? I keep looking at this one down here, but network 2 is actually 4 to 20 milliamps to percentage scale. Not enough coffee yet. Okay, so that's network 3. That looks good. MD50, MD62, gorgeous. Okay, moving on. So now we're getting to this page, and I've done this with a number of classes. On this page, there's always questions. The questions arise because they're like, what is this? Where do I find it? Where's this? Where's this? What's going on? So if you're on a page like this, it doesn't exactly describe what I'm looking for, flip to the next page and hopefully it will tell you exactly where to find those guys. So we're looking for some comparator instructions. We're going to look at less than or greater than. Those guys are found right here. Okay, and then we're also going to make use of increment and decrement there in the math functions. Okay, so let's start off with the first one. First one is just a standard normally open contact right here. So we're on network 4. Let me type in this name here before I neglect to do that. So this one is going to increment and decrement instructions for the pump speed control push buttons. So these push buttons are going to be on our HMI. So we need an instruction, a normally open contact here. We can drag it down until it's green and drop her in. That is found up here in your favorites and in your basic instructions. Okay, so if we look at basic instructions, it should be as there as well. If I scroll up here, bit logic operations are right here. Okay, so number of places where we're finding those guys. Okay, so that normally open instruction looks for a 1 in the memory. When I press the push button on the HMI, that bit of memory is going to go from a 0 to a 1. So as long as it's a 1, then it'll go to the next instruction. So remember, it's not the path of current, it's the path of logic. So the logic will then go to the next instruction. Next instruction is hard to make out, but it is looks very similar, but it has this less than. So we're going to grab that one. That one we said was in comparator instructions, right? So we need this one right there, less than, right? So we're going to grab that guy, drag it down until she's green. Looks good. And then we need this increment. That increment was in the math functions, I think. Yes. Okay, so math functions as well. Okay. And again, if you can't find something, you can always grab a box from the top there, type in the instruction that you're looking for, and you're ready to rock. Okay, so now we have 3 instructions there. This one here is first looking for the address. Okay, so I'm going to click on here. This is a Boolean instruction, so it either has a 0 or a 1, right? Whereas this bad boy right here is a double word. It has a disgusting amount of 1s and 0s where it can keep its information. So this one, if I click on the instructions, should only come up with the Boolean ones that I have already. So this one is supposed to be M1.3, so make sure that dyslexia does not hit and you put in the correct address there. The only reason why it says increase push button 2 for the HMI is because I had 2 screens, and so when I was working on this was my second increase push button on my HMI, so you can name it however you wish. Okay, the next one is MW66. So again, you're typing in MW66. Okay, once that's there, then you're putting the name in there by right-clicking and putting increase and decrease output. Okay, so that MW66 is going to be used in a number of places. It's actually used over here as well. So all of these will change simultaneously. And you'll see on the next line, I'm also going to make use of that address twice again. Okay, this one's going to increase the voltage, so it's going to increase the output to my analog output. So I'm going to make use of a memory bit here, and that memory bit is then going to be translated to my actual output. Okay, so because I don't think I probably could, but I decided to use a memory word. I can't remember why I decided to do that, but it could have been just that I wasn't able to put an actual output here on the increase. I can't remember my thought process on that. Okay, this value right here is going to be 13,824. That's a random number. So where did I get that from? Well, I got that from the fact that if we go back up to network number 1, we can see that for Siemens, on the analog input and the analog output, it changes the value between 0 and a maximum of 27,648. Other things like Allen Bradley would have a standard 32,767. This one uses 27,648. I believe because a number of bits are used in the Siemens for faults and stuff like that. So if you take out your phone and you take 27,648 divided by 2, you get 13,824. So it's not actually a random number, it's half of the maximum output there. So the reason for that is that, let me bring up the other stuff, there we go. So the reason for that is that the output, I believe we're going to be making use of this output right here, output number 1, I believe. The pump that we're using is only good for 5 volts. So it takes a 0 to 5 volt signal. So the PLC, the output, it's always backwards on that. There we go. The output right there is going to punch out a 0 to 10 volts. Well, I don't want to have double the voltage going to the pump. So I want to limit this to a 5 volts output. Okay, so that's the reason why we're doing that. Okay, so let's go back to this guy. What else is missing? So the other thing that's missing is that right here, so you can you see that? Yeah. There's a little triangle in the bottom right-hand corner, and I can change the instruction type here. Okay, so I've decided to go with an integer. It automatically chose integer because I put MW66, and that in my tag table is right here. It was already described as a data type integer. Okay, so that's why mine came up right away. You're going to have to choose the integer, put in %MW66, and then you can put in the value of 13,824. Okay, that looks like everything's cool corresponding to this one. 1.3, that looks good, beautiful. Okay, so the next thing that I failed to mention on the next page is that in order to put a new rung in, we're going to click right here. So right beside the increase push button HMI, and we're going to come up here, and in your favorites, there should be open branch. So we're going to do that. If by mistake you do twice and make use of this branch, but leave this one open, the PLC is going to be angry and won't be able to compile. So make sure you only put one in there. Okay, so again, I came here, I put this one in, the open branch, and I just clicked it once actually, and it brought in a new branch there. Beautiful. Now, I want to save some time, so I'm going to take all of these guys. So I'm holding my mouse down, grabbing all those bad boys, hitting Control C, clicking here, hitting Control V, and I've got a carbon copy of the previous portion of my program. Okay, this one right here is not my increase push button. This one is going to be my decrease. So you guys are going to put in %M1.4 and then label that guy as decrease push button on the HMI. This is staying the same, so MW66 is remaining the same all the way through. But for this one, it says if I want to be greater than 0. So I'm changing this to 0. Okay, it's still staying as an integer. Okay, this is just a single word, so it's going to be an integer. But I still have the same instructions here, right? So be careful with this. If you carbon copy it, your push buttons will not react properly. And then you'll actually have to, like if you screwed up, you'll have to actually modify the value. So you'll have to put it back to 0, most likely once you go online. So let's go to here, and I click on this once. So I'm left clicking on this once. In the top right hand corner, that's where I can decide what type of instruction this is. So I want to say if it's greater than 0, then go ahead with this instruction right here. So the way that this works is if this is true and this is true, then increment the values. As soon as this is no longer true, this guy can no longer increment. So that's going to stop us at 5 volts. We also don't want to go less than 0. So as long as this push button is true and we're greater than 0, then I want to, careful right here, I want to decrease the value. So again, in the top right hand corner, I'm going to change this to a decrement. And then I believe we are good to go. Okay, so that takes care of network number 4. Excellent. We're rocking, guys. We're rocking. Okay, then we're going to go for network number 5. Network number 5 is a Normex and a ScaleX. Again, come on, Pete. Let's get on the right screen here. Okay, let's go down to network 5. Let's put in the name here for network 5. So this is going to transfer the increment and decrement push button values to analog output 0. So I made use of a memory word here that is increasing and decreasing. I think this is the coolest thing because it's able to increase and decrease the same memory word here. And then we're going to transfer this MW66 out to QW96. Okay, so why are we using QW96? It's very faint. Hopefully you can see that. That QW96 is because if we go here to device configuration, so I'm double clicking on device configuration, and right here I can right click on this analog card right here, going down to properties, and we set the analog outputs. So if these are small, then you can increase your inputs and your outputs, and specifically channel 0 is a voltage, channel 1 is a current. Okay, so the voltage is 0 to 10, and the second output is QW98. So let me show you that right here. So this one right here, if you look at the second one right here, sorry, the first one right here, my hand's in the way, but this bad boy right there, that's the one that we're going to be making use of. Okay, so that one is set for voltage, and we want a 0 to 5 volt signal sent to the pump. Okay, you can see that I can change it, but I want to keep that at voltage. And you can see that this is grayed out, so I can't change that address. That's always stuck as %QW96. Okay, so memory is M and outputs are always Q. Okay, hopefully everybody's cool with that. I'm going to go back to my main OB, so I'm coming back down here. Excellent. Let's go back to just the display capture. Okay, looks good. Let's drop this bad boy down. Let's move this bad boy over. Okay, so we got network 5 here. We need a NormX and a ScaleX. Okay, those guys are conversions. So NormX, ScaleX, beautiful. Okay, and we're going to again make use of %MW66. This guy right here. Okay, as soon as I put that in, it changed it to an integer, so make sure that that's an integer there. That one is going to go between 0.00. Okay, and now I limited it to 13,824, but the actual MW66 goes from 0 to 27,648. Okay, I'm going to put 0.0 there. Okay. The output is going to be a memory word. So I'm going to do, looks like I actually used a double word for some reason. Okay, so MD70 there. Okay, so that's just kind of a placement holder for that information. Okay, the last one that I used was MW66, so I went up by 4 there. This was a single word, so I probably didn't need to go up by 4, but I'm just trying to keep the same thing all the way through. And I'm going from an integer to a float or a real value there. Okay, that value is being placed into here. So you guys are typing in %MW70. Okay, you're going to have to give it this name, increase, decrease, NormX output, or whatever works for you, like whatever makes sense to you. Okay, and then we're going to use 0.0. And the output on this guy is, again, going to go from 27,648. Sweet. These guys are angry at me. That's because I have a real value here, but I don't have a value here yet. And so this one, remember we said that this has to be %QW96. It's interesting, it's not coming up yet. Let's see. If I say %QW96, see if anything comes up. Okay, looks good. It's still angry at me. Why is it angry? Because I have to change the data type here. That QW96, I believe, is a double integer as the output there. So I'm going to put double integer. Ah, yes. Now everything's cool. Okay, so hopefully everybody's good in that we've got everything here. Let me get rid of this thing right here, and then we can see everything that I'm doing. Okay, so let's see. We got 0, 27,648. MW66 is then going to be transferred to this double word here. This double word is then going into this bad boy. This is normalizing it from 0 to 100%. Then that 0 to 100% is now being scaled between 0 and 27,648. If you have a better way of doing this, or you can explain it better to me, please leave it in the comment section below. This is the way that I understand how to do it, but there may be a much easier way to transfer this memory word to an output. Okay, I'd really be interested in hearing that. Okay, so we have a real to a double integer. Save your work after each network addition. Double click on device configuration. So we're saving the project so far. Okay, so mine is just, you can see that I just have my working copy here. Make sure that you put your name so that somebody doesn't delete it on you. And I believe those are all the networks that we need so far. So what we're going to do is we're going to double click on device configuration. We've already done this. Okay. So here it's just saying make sure that the output is set for voltage. Okay, so we did that already. Okay, sorry, there are other networks. We need network 6 now. Okay, so network 5 is done. I just jumped the gun on showing you the device configuration. So let's go for network 6. What's network 6 doing? It's doubling the output. Okay. So why was that? That's most likely why did I do that? Double the analog output in order to create an accurate zero. Oh, okay. So the reason why I'm doing this is because remember that the pump is set for 0 to 5 volts. So I limited, sorry, I keep pressing the wrong screen. I limited the value to 13,824, okay? But the actual instruction goes to 0 to 27,648. So in order to show the value properly, I'm going to double that value now. Okay, so I'm going to use network 6. So you can see that, like, putting in, I couldn't remember what I was doing there, but by reading what I had as the name for my network 6, then it tells me my thought process behind that. Sweet. Okay, so we're going to make use of a multiply. Okay, here it says the multiply instruction is found in the math function. Okay, so network 6. I think it's interesting that most of the world uses maths. In Canada, we call it math for some reason, and here it's saying math as well. It'd be interesting, like, I'm just interested. I find it funny that it's not called maths function, but regardless, stay focused, Pete. Let's do the multiply. So we need this guy right here. We're dragging that guy down. Okay, so again, like I was saying, I kind of set this up so that every network is doing a separate thing. So because this is like your first time looking at PLC programming. So hopefully this makes it a little bit easier to discern what everything is doing within your program here. Okay, so this one here is going to be MD70. So this guy right here. Yes, that's right, because MW66 was limited to 13,648, right? That was reflected to MD70. MD70 was then sent out to QW96. So by limiting this to half, we limit this to half. So this only goes to 0 to 5. But I need a display on the HMI to show 0 to 10. So I've now got to change that back to double the value there. So I'm using MD70, this guy right here. So this guy right here looks good. And we're going to double that value. Okay, and the output is again going to be a double word, so %MD74. Looks good. Okay, and then I've put my names in here. That's the 0 to 5 output signal display. The reason why I'm putting all the names in, I've probably said this already, is because I'm going to grab these for my HMI, and so having names really simplifies knowing what all these different double words are for. Okay, looks good. Yeah, looks good. This one's already changed to a real value. Okay, so automatically changing to real value. Okay, let's scroll down. Network 7. So this one is going to double the output. Network 7, now we're working on stuff for the HMI. So network 7 is the 0 to 100% to the HMI display. Okay, we're making use of a scale X. So I'm just going to grab this guy, drop her down, and you can, hopefully you're finding that it's easier to navigate through this now. You can see that hopefully I'm going a little bit faster than I was before. Okay, I'm going from real to real. Okay, I'm going to make use of MD74. Okay, so I doubled this value. Now I've got MD74 to make use of, and I'm going to use that and then go to the actual display. So I'm translating that from 0 to 5 volts now. Okay, and the output is going to go to a memory word. So I'm making use of memory words because the display is not an actual output, right? So I'm making use of memory words to go to the HMI. Okay, that looks good. Careful, because I'm on cruise control again. This is not 82. I keep looking down here. It's MD78. Going too fast. Okay, let's see. And I screwed that up. That one's supposed to be a double integer for some reason. Okay, let's make sure everything's cool. 0, 100. Holy, what is this smoking here? MD74, scale X, we're on network 7, 0, da, 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 and the output is MD78. Okay, good. I was gone, but I'm back now. Okay, network 8, let's see. That is the 0 to 5 volt output to the HMI display. Okay, looks good. Making use of the scale X again. Okay. Okay, let's go through this a little bit slower so that I don't mess this guy up. So this is 0.0. This is 5. Okay, and the input in there is again MD74. Looks good. That's already changed this to a real. And the output there is MD82. Nice, which also changed this to a real value. Okay, are we good? Network 8, 0.5 volt output to HMI. Looks good. MD74, 0, 5, MD82. Gorgeous. Okay. Phew, that was a disgusting amount of work. Let's save our work once again. Okay. Compile the project, download it to the PLC, turn monitoring on and off so we can make sure the values are correct prior to creating the HMI screen to match this program. Very nice. Okay, so hopefully this has only taken us, I can't see, it looks like it's taken us possibly 37 minutes to get this far. So hopefully you're with me and we're still in the first hour of the second class, or maybe you got all of this done in the first class. Nice job if you did that. So let's download this guy. So again, we're going to come over here. Okay, we're going to right click on PLC here and we're going to download it to device. So I'm going to download the hardware and the software here. So who knows what the previous class downloaded to the PLC. Remember, the same PLC is sitting on your desk, right? But it's used by a number of classes. So maybe the intermediate guys were working on it, who knows. So let's download the hardware and the software to it. Okay, that's going through. Now, one thing that I failed to mention there is that like mine's going right to the PLC, right? Because I've already uploaded something prior to starting the video. In the lab, it says to make use of the Ethernet connection. That has been changed in the lab. So every time that you see Ethernet connection, we're going to use the Realtek family controller. The reason for that was that prior to this summer, we're always like connecting and disconnecting the HMI cable on the back of the computer. So Eric came up with the great idea of putting in another Ethernet connector on the back of the computers so that we can always be hardwired to our PLCs. And we're on, if we use the Realtek family controller, then there's no way that we can actually get onto the network and screw up Ted's IP addresses on his Schneider PLCs. So this will eliminate any changing of IPs within the room. So, but remember that in the lab, anywhere that it says Ethernet connection, please scratch that out and put Realtek family controller for our lab. Okay, so that guy is there. Let's get rid of everything here. Okay, and let's go online here. And let's see what's coming in here. Excellent. Okay, so we still have 8 milliamps here. Okay, everything's working out. I'm going to change this to hexadecimal. So you may see this as a hexadecimal. Okay, so to change that, we're going to right click, and before I started, I should have said we're looking for greens right across. If it's orange, then upload your program again, because there's a difference between your computer and the actual PLC. Okay, let's bring up everything here. So we have 8 milliamps right here. Okay, so that 8 milliamps is being translated to here, but we're seeing the hex value. So I'm going to right click here, go to display format. I'm going to go for the whole network. I'm going to go to decimal, no, not decimal. I'm going to go to floating point because it's a real value. There we go. Okay, so we have to change it to floating point to get that value in. Sometimes as we see scrolling down, we may have the same issues where we need to change the display. So 8 milliamps is 25% of the range. So we've changed this 0.25 to 25%. Beautiful. Okay, that is 20 centimeters. So we're going between 10 to 50 centimeters. So 25% is 20 centimeters. Okay. Here, let me show you how that changes as well. So I'm going to change the current here to 12 milliamps. 12 milliamps is 50% of the range. Okay, that's good enough. Okay, so here we can see that we have 13,930 going in out of 27,648. That's being normalized to 0.50. We can see that the same current, got 12.07, 12.06 there. Okay, then down here, network 2 is showing us 50 centimeters. Sorry, 50%. And then on our scale between 10 to 30, so 10 to 30, there's 40 increment, like graduations there, right? So half of that is 20 plus our 10 is our base there. So 50% is 30 centimeters in the tank. If I change this to 16, then we should see that reflected as, come on, there's a little bit of delay there. There's 16, that should be 75%. Ah, yes, 75%. And 40 centimeters in the tank there. Beautiful. Okay, let's take a look at these guys. So this one here, we have their increment and our decrement, but we do not have any push buttons on the actual HMI. So what I'm going to do is I'm going to modify this value. But looking around, I neglected to grab my meter. So give me 30 seconds and I'll grab my meter, and then we'll put that into the analog output, and we should see the voltage change on the output as these increment and decrement. So give me 2 seconds and I'll be back to you. Okay, so now we have our meter set up here. So you can see here that I've got 0 volts coming out of this guy. So what I'm going to do now is remember that I can't actually press the push button on the HMI because we haven't created it yet. So what we're going to do is we're going to right click on this guy. Wrong screen, donkey. Right click on this guy. And we're going to modify this to a 1. So watch this. You'll see that the values are starting to go up. I'm going to modify this quickly to a 0 to stop it. So right now we're at 4766 out of a total of 13,824. So if we look at the meter now, it looks like we have 1.71 volts coming out. So a couple of things that you may have noticed. For one, we've got a negative value here. So some of the analog outputs were miswired in that your positive is actually your negative, negative is the positive for some reason. I think that after 40 different boxes, they were backwards. And then you'll see that I'm on analog output number 2. So double check because we're supposed to be on analog output number 1, but I think those two were miswired on my box here. So I'll have to rewire those guys. Regardless, we have 1.71 volts coming out. If I increase that voltage again by modifying this to a 1, you can see that voltage going up. I'm going to modify it to a 0 now. So now we're at 3.1718. Okay, so let's scroll down here. So those guys are coming through here. Our value right here is 8841 out of the 27,000, out of the, number 27,648, sorry. And then here it looks like we've got 64% of our voltage output. Okay, so that's just being placed here. So 64% would be going to the percent scale output on their HMI. And then this value right here, 3.19, is fairly close to the voltage that we're seeing on the meter there. Again, slight difference there between the PLC value and the value that I'm seeing on the meter there. Beauty. If I allow this to increment up, so I'm going to modify this to a 1 and let her go, it'll get to 5 volts and then stop. Excellent. So you see there's a resolution issue on my meter there. It should say 5 volts. It's saying 4.96, 4.97, right? So now we got the 5 volts going to the pump, and the pump's going at 100% speed there. Beautiful. So let's, if we modify this to a 0, you would have seen that this instruction right here, as we got to 13,824, this instruction was no longer true, so we're not able to increment the value anymore. Okay. This one is still available because we're above 0 still. So I'm going to modify this one as a 1. So remember, if I push the push button on the HMI, it would change the memory from a 0 to a 1. This instruction here looks for a 1. So I'm going to modify it to a 1 so it's true. This is true as well. And you can see that the voltage is decreasing. I'm going to modify this to a 0 quickly before it gets down. Right? And now we're at 1.55 volts. And let's see the voltage that we have down here, 1.56, looks good, which is 31% of our output from 0 to 5 volts. Beauty. So now we've got our scale percentage output. We've got the actual voltage that's going to the meter now. So now we've got an actual voltmeter that's being shown on the display. Okay, just to finish up this video, I will modify this to a 1 again, and we'll see that the voltage goes down and it gets to 0 and then stops, so it doesn't go into a negative value there. Looks good. Now let me show you one last thing. So say we screwed this up. So let's put this one as an increase here. Okay, now that I've changed that, I have to quickly download that to the PLC. So this is the one thing that I've seen people mess up here. So we're going to go back online here. Okay, it looks good. I'm going to modify this to a 0. Okay, I'm going to modify this bad boy to a 1. It's going to increase the voltage just like we saw before. Okay, I'm going to modify this guy to a 0. Okay, so we got to 13,824. We're at basically 5 volts there. And so that's working properly. But remember, this one was supposed to be a decrease. Watch what happens. It says if this is pressed and it's above 0, then increase the value. So I'm going to modify this one to a 1. And this is no good because we're going above 5 volts there. Right now I'm up to 7 volts. It'll probably climb. Let's see, just keeps going, right? 11 volts, 12 volts. So let's modify that to a 0 now. Okay. So at that point, it actually like flipped through, right? So then it went to negative 32,768. But you saw that it was just above that. So let me do that one more time. I didn't stop it in time. So let's see, if I modify this to a 1, then that's good. And it's going to keep increasing the value now. We're at 8, right? So things are all messed up here. So just keep in mind that if things are messed up like this, you can modify each of them back to a 0. Then you can double click on the value here. No, you can double click on this value right here, and you can modify. So I double clicked on the one above, and I'm modifying that value back to 0. Okay, so that brings us back to 0, back to our starting point. Okay, then once you notice that this was messed up, you can change this back to a decrease, upload this back to your PLC, and then everything should be good. So you can modify the value of the MW66 while you're online there, in case it goes above 13,824 or below 0 there. All right, guys, I think that takes care of this video. Next video, we're going to start on the HMI. So far, just as a recap, we've got the first line here that looks at our current, second line that gives us our percent scale going to the HMI, third network giving us our centimeters between 10 to 50, so we're at 40 centimeters now, and then we have 2 push buttons on the HMI which have some limits, so they're going to limit it to 5 volts out, going to the increment and decrement. That's going to change our voltage to the to our pump from 0 to 5 volts. We have a NormX and a ScaleX, changing that value MW66 to QW96, so that actually sends the voltage out on those analog outputs. Then we have to double that value, we use this MD74. That's going to go to the 0 to 5 output signal display. Okay. Then we have a percentage scale here, 0 to 5 to percentage scale. And then finally, we have a digital display here that's going to show us the actual voltage that's mimicking, with a resolution that's fairly close, the value that we're seeing on the meter. All right, guys, I'll finish off there. Hopefully everything was clear and you were able to complete this so far. Keep going. The next video, we're going to keep going on how to set up our HMI to graphically display all of the information that we've created in our TIA portal. All right, guys, thanks very much. I'll see you soon.